This problem is about galvanometers and shunt resistors. This is the problem as given on the exam. Galvanometer has a coil resistance of 100 ohms and requires 1 milliamp for full deflection. If we want to make it into a 200 milliamp full-scale ammeter, then we need to connect a resistance. Now, I'm not going to go into a lot of detail about what I did wrong here. Bottom line is I just can't divide simple numbers. This is wrong. Don't do this. If you're taking an exam and you do this, you're going to get the problem wrong. Try to divide correctly. Use a calculator if you need to. So, this is the correct answer. Anyway, let's go through how to find those numbers. The ammeter we want only needs 1 milliamp to operate. 1 milliamp maxes out at scale, and we want to measure 200 milliamps. So only 1/200th of the current can go through the galvanometer. This means we need to connect a resistor in parallel. Because if we do it in series, then all of the current would go through both the galvanometer and the resistor. So let's look at a diagram. This is a pretty simple circuit. The galvanometer is across the top, and the shunt resistor is in parallel with it. The problem gives us the resistance of the galvanometer, 100 ohms, and we know the input current is 200 milliamps, and we want the current across the galvanometer to be 1 milliamp. Since we have 200 milliamps of total current going across the circuit and only 1 milliamp in the top resistor, the bottom resistor must take the other 199 milliamps. You could find this with the junction rule, but it's pretty simple to see in this case. So now let's use the loop law. Going clockwise around the loop, starting at the lower left, we first pass through the galvanometer. The voltage there is current times resistance, and this term is positive since it's in the direction of the current. The current then passes through the lower resistor backwards, so we subtract that voltage across that resistor, which is again current times resistance. The loop law tells us this is equal to 0. So now we rearrange those variables to get this lovely equation. Let's go ahead and plug in the values. Here's the fraction I wasn't able to divide on the exam. I'm still not really sure how I managed that, but if you do flip the fraction, you will unfortunately get an answer that is one of the other choices. Be careful here. The final answer is 0.5 ohms.